Hey, thanks for coming to our breakout session. We are very excited to share with you some things that we are doing in Unity and some best practices to help solve ANRs. I'm Otto Oliveira, Senior Software Engineer in the Unity Studio Productions.
I'm Joseph Burchett, a Senior Partner Engineer at Unity.
And I'm Neil Skinner. I manage the Google team, the Android team at Unity. So this is the agenda that we're going to talk about today. I'm not going to read them verbatim, but we're going to start with what an ANR is for those that don't know, some data points, some investigation tips and tricks, some ways to debug them, and what we are doing to help you out with them.
All right. Yeah, so many of you may have come to this talk and already know about ANRs. But let me give some basic context for those who don't. So when an application not responding, when the main thread on an app activity is blocked for too long, we got this application not responding ANR error, as we can see in the video over there. There are 5 types of components that can trigger ANR. Content provider, broadcast receiver, services. But in this talk, we're going to focus on the activity, which affects most of the games. So when the ANR happens, the user obviously has to close the app, restart the game, and the game state may be lost. So that causes a lot of frustration. And usually the ANR timeout is 5 seconds, but some OEMs can change it. So for instance, some Samsung devices set the ANR timeout to 10 seconds. So that's something that's not everybody knows about that. On the Android vitals, there are 2 types of bad behavior thresholds: overall and per device. One obviously affects all devices, and the other impacts only affected devices. But ultimately, the discoverability impacts your revenue. Use this. It's worth mentioning that the main thread is also named UI thread in the documentation, but they are the same thing, especially in the Android developer page. So in this Android profiler screenshot, Android Studio profiler, we can see that the first line represents the main thread, which receives the application ID, which in my case, it is com.game.unity. And the second line is the Unity main threads. So do not confuse them. One is responsible for the app activity work, input, native UI, app callbacks, and the Unity main threads is responsible for the engine and your game code. Obviously, Unity uses more threads to handling rendering, physics, job systems, etc., asset loading. So for instance, we could have a blocking operation on the main thread, which will cause an ANR, but Unity could run normally. As we can see in the video, the animation on that button keeps running, even though I force the main thread to sleep. So the main thread is blocked. No inputs are passed over to Unity. So as you can see in the white dot, but it's there. It's running, and it's just fine. So the render commands, logics, physics, it's all good. So last year, Unity and Google started an engagement to provide better documentation and tools for the developers to better understand the ANRs. And also to identify gaps in the Android Vitals page. But we had a problem. We didn't have any live game to experiment, debug, identify common causes of ANRs. So we had a lot of questions from folks from like you that, okay, what happens if I block my main thread, my Unity threads by running some 30-second long operation on an update function? Like, let's say if I'm saving the user state and it's completely stalled Unity. If I keep pausing and resuming it, it will hang if I do that. And what happens if I allocate 1 GB in a short period of time, 1 GB in memory? Then we started this simple app with basic functionality, simple UI, and start evolving it to more complex scenarios to mimic common behavior in our games. We also integrated backtrace and crashlytics to better understand how the reporting services are showing this data and what can be improved in that front. So yeah, as you can see in the video, we start very small, and then we add more complex scenes, allocate a lot of textures, so on. It's just our sandbox app just for doing the initial investigation on the ANR. So we have some findings with this. We noticed that with those findings, we could narrow down some root cause of ANRs, and Joseph will elaborate on that later. We started a comprehensive documentation that is currently being published on the Android Vitals, Android developer page. We will have a link for that in the end. All of that was important. It gave us a lot of ideas and things that we can work on. But we needed to test in real life. And probably with a typical mobile game, with ads, packed with SDKs, plugins, things that are common in our games. And in a Unity version that is not too old, but not the latest LTS. So that happened last year, so that game was using Unity 2021. And since the beginning of that engagement that started last year, we have established close collaborations with many groups inside Unity. Iron Source, Level Play, and Supersonic are some of them. For those who don't know, Level Play is our ad mediation platform, and Supersonic, a mobile publisher. So they allow us to use Snake Crusher to experiment in 4 releases in total. And what was the plan? To run more live experiments than previously done, because the sandbox wasn't live. And from the previous findings that we obtained with the sandbox app, we could develop some solutions and analyze the metrics in a live environment. And this gave us more confidence that we could ship these solutions in Unit 6, or, when possible, to backport it to an LTS version. Throughout the engagement, we also share our findings with the Android Vitals team. For instance, to increase the ANR report size, how the stack traces or call stacks are displayed in their page, things like that. Once we integrated with backtrace and crashlytics, we identified the game had several debug log messages, non-fatal errors that affected our ability to understand in which state the ANR was happening. So if I open backtrace or crashlytics, probably you guys know there's the logs and so on. But it was too noisy. It was difficult to understand. So we removed as many logs as possible, and we added meaningful breadcrumbs. We also updated all SDKs, add SDKs, other plugins. And on top of that, we updated to the latest 2021 version. So on that moment, back in time, I was using 2021.3.10, and we updated to 2021.3.27. And that resulted in a drop in the ANR rate from 3.5 to 0.4%, roughly. I couldn't find a better screenshots, so that was the results. Unfortunately, the game in the previous build did not have symbol location, so we could not understand what exactly impacted in this drop. However, it's a good indication that housekeeping is a good practice. Okay, after the first release that we see on the, well, I think everybody knows that, but anyways, the little square icons over there. After the release with symbols and the reporting services integrated, we could have a better picture of the remaining ANRs. So we identified some issues. The engine pause synchronization with the Android activity was a critical point. So we started running more live experiments to solve them, to try to make it better. And Neil will elaborate on that later. We also learned that the symbols and the symbol management and uploading to the reporting services, Crashlytics, Backtrace, or even to Google Console was a pain point. So we understood that we could improve that as well. And I think that's pretty much it. Let me pass over to Joseph. I don't know.
So as a partner engineer at Unity, my main role is to act as a technical advisor to customers. And a lot of times when I speak to customers, especially about ANRs, and there's a lot of them, there's a lot of common ANRs and issues that pop up. So what I'm going to do through my different collection of slides is walk you guys through these very common ANRs that I'm sure a lot of you see already in Google Play and all the other different places, to kind of make them a bit more clear and you understand what exactly is going on here. So these are all the different, I mean, there's a lot more than this, obviously, but these are just like the most common ones that happen. So I'm gonna try and break these down. So kind of the first one, which native poll once, that is like by far the most popular one that people see the most. I have great news. You can ignore it. You don't even have to think about it, because the actual root cause when you see that in Google Play is that it's very hard to understand what's going on there. And typically, like I'm saying here, it's just an indicator of an unresponsive thread, essentially meaning that when you see this, that means that whatever issue would happen when the threads were blocking each other had already happened. So essentially, when you see this, look below it, and that will actually give you more insight and information into what exactly was happening. So this means nothing. Don't even really think about it. So if you see it a lot pop up multiple times, remember, just look below it. So the next one, which is pops up a lot, you'll see on perform pause. So just to kind of get a quick understanding of what's going on with this one, is that when Unity, when a Unity application goes into the background, the Android platform in its activity lifecycle, it triggers the on pause along with a whole bunch of other functions. So what's happening there is that the Unity player activity notifies that the Unity runtime engine that the activity has now paused. So they're communicating that way. As soon as that happens, the Unity calls every mono behavior that has the on application pause event. So essentially, any logic you have and any mono behavior inside of that function, it's now going to go through and try and execute and run all of that. So this is why a lot of the times when an ANR happens, it's in the background because whatever logic you have running in that particular function it's trying to process it, and things are like it's having issues with it, and that's why you'll see that one. That's all that's really telling you, is that there's an issue inside of the on pause, or there's an issue that you're doing something in the game or application when it's paused. So the next one, which is one that pops up a lot as well, is the update display internal. There's a lot of stuff here, but just to sum it up, essentially it just means that there's some sort of excessive GPU usage going on somewhere. Super clear, not really. So all that really means is that somewhere in your application where you're utilizing the GPU, it could be like with physics, it could be like with your shaders or your lighting or anything like that, somewhere around there, it's not very optimized and it's causing a lot of issues. That's why this one is so hard to actually figure out what's going on, because it can be happening anywhere in that code. So like that's when you see that one, just the first thing you should be thinking about is like, okay, there's something going on in my application where I'm like utilizing maybe a lot of lighting or some really complex shaders or something around that area. That's where you should be looking. So this next one, you'll see like native Unity send message. So really all that's happening here is that this is just telling you that when Unity is communicating with a third-party application, third-party SDK, typically it's their built-in native code, like in Java or Kotlin. And the way that Unity communicates with that is through the JNI, which is called the Java native interface. That's how they talk to each other, and they do it using messages. So when you're seeing this, that means typically that there's something going wrong or taking too long when Unity is trying to communicate with some sort of SDK that was built in native code. So when you see this one, just look at those third-party SDKs. Something is wrong there. And this is another one that's really vague. And so all a binder is that this is kind of like far away from like Unity. Most people are like, who are Unity developers and you're not a native developer, you really won't ever have to be concerned with this or think about this at all. But when you start, once again, introducing code that is utilizing native code in your project, a lot of times those particular SDKs will utilize like this type of a binder call or some sort of communication tool within there. So you'll really only, once again, we'll see this when you're dealing with native code in some sort of way. The most common way is, once again, inside of like a third-party package, third-party plugin. So when I also talk to customers, that one pops up a tremendous amount, like a lot. In fact, when the conversation starts, it's always, ads, Joe, it's ads. What's going on with the ads? It's ads, ads, ads. So just to kind of go a bit deeper into that one, when we talk about ads, most of the time, it's not necessarily the ad SDK itself. It's like how that's set up, like 99% of the time, it's working fine. The real issue is that a lot of these ad SDKs, they utilize the web view, and within that web view, the ad providers, they'll load in a whole bunch of stuff. They'll load in a lot of JavaScript. They'll want to have lots of tracking analytics inside of there. So there's all kinds of things going on. They might be loading in some very rich content. There's like playable ads that like sometimes you can put in your game. So there's a ton of stuff going on in there. And what happens there is that web view then becomes very heavy, becomes very active. It takes up a lot of memory. It takes up a lot of CPU. It's doing a lot of stuff in the background. And that's why usually you'll see like in Google Play, you'll see like sometimes you'll see ANRs pop up saying like WebView or something related to that. But that's primarily why the ads become the issue. It's the web view. It's not the actual SDK itself. So and then the next big one is third-party libraries. In the previous one, I was kind of talking about that a little bit. So whenever you integrate in a library that's using native code, who knows what they're doing? Especially if it's like something from like a random GitHub repo or something like that. You have no idea what they're doing in there. So because of that, the person who made it could be doing some like really bad practices inside of native code. Because like just like in C Sharp, there is a certain way you should do optimizations, a certain way you should be utilizing different aspects of the platform. The same thing goes with native code in Java, especially Java, if anyone's ever used that before. So that's the same thing that happens here. So if you're using a third-party library that wasn't optimized very well, then that's going to most likely trigger a lot of issues in your game, which in turn could cause an ANR. Native code. Once again, people who use Unity, they're very familiar with using Unity. They're not very familiar with doing native code. You're familiar with C Sharp. You're familiar with the .NET platform. You're not so familiar with Java or Kotlin or Swift or Objective-C. And most of the time, when I talk to them, no one wants to deal with any of that stuff. So when you have someone that who wants to start fiddling around in the native code and doesn't have a lot of experience on how to actually do things there, that's when you can see a lot of issues. So a great example was I was speaking to a customer a while ago, and they were saying like, I'm getting all these ANRs, there's all these horrible things happening. I said, okay, well, did you create like a custom activity and like start fiddling around inside of like the native code? They say, oh yeah, like we added this and we added that and we added that. And I said, why did you do that? And they said, well, we wanted to do something cool and we pulled something from Stack Overflow. We pulled that here, pulled this here. And now nothing's working, fix it. So when you get in there, you need to make sure that you actually fully understand how to use Java or any of the other native languages before actually trying to implement something in there. So yeah, those are some of the common areas that I see happen. And here are some other ones, long-running processes. What I mean by that is anything in your code that may require or possibly could take a long time. What I mean is like a network call, or maybe you like going back to the physics example, maybe you're doing some crazy physics calculations or something, or maybe you're doing some like IO to the actual like the saving stuff to the device or something like that. These can all be considered long-running processes. And what can happen with that is that when you have like a Pixel or you have like a Samsung device or you have something that is already really equipped to handle that type of processing because the hardware is so good, then you're going to be fine. But when you start thinking about mid-tier devices and low-end devices, that's when things start breaking down because the hardware just can't handle doing these very complex operations. And then what eventually happens is, unlike a Pixel or something, it'll take much longer, which then in turn will cause an ANR to happen. So low memory. This is actually one that a lot of people don't think about. So when your device gets low memory, that's not necessarily the thing that causes the ANR. The thing that causes the ANR is when your device starts getting to low memory, like you're getting near, like, right before that exception gets thrown, the garbage collector is going to attempt to try and clean up as much as it can. It's going to try and do whatever it can to start trying to, to remedy this issue. What can happen there is that the garbage collector sometimes may actually start blocking certain threads, or like in this case, possibly the main thread. And when that happens, once again, on lower or mid-tier devices, that may actually slow things down because it actually now has to work harder to clean up more memory and other things. So you really need to be cautious about that. Once again, you probably won't notice this on like a Pixel or a Samsung, but when you get to those lower end devices, that's when everything starts to break down. So make sure to be cautious about that. And then of course, as I brought up multiple times, low end devices, when you get those really obscure hardware for Android devices, which we all have to deal with at some point, things can just get bad real quick because it just can't handle a lot of the stuff that more of the higher end devices can handle. So I get that a lot from customers as well, because they're just wondering like, why is everything just falling apart, but it's working great on a Pixel? It's because the hardware, it's got like 1 gig of RAM on there. It can barely even do anything. Some devices have like 500 megabits. Those devices they won't be able to do it. So just to kind of just start off with some general optimizations and debugging, do this. Always do this. Always make sure to upload your symbols to Google Play, because if you don't, then you're going to get this, which is not useful at all. But then once you upload the symbols, you'll get more information. In some instances, it may not still be as clear, but what this will help a lot with is when you want to report a bug to, or sorry, report an issue to like Unity or some other place or something, providing this type of detail is going to help everyone on your teams, or like I said, if you're giving, it to Unity, help us understand better what is happening and potentially where it's happening. Like you can see like, Crashalytics, you can see Logger, Unity event, and so on. So it's always very important, existing projects, new projects, to always upload the symbols. So just to kind of go a bit deeper into some more optimizations and debugging techniques, which I'll get to in a second. First thing, initiate SDKs asynchronously and stagger SDK initialization. This is the thing that I hear a lot about. Like I'll ask, so how are you initializing all your SDKs? When do you do it? I'm like, well, we just fire them all off right in the beginning. It's like, no big deal. Well, that's why you're getting ANRs. So a great tip, and it's a simple thing to do, is like initiate the SDKs asynchronously. Essentially, don't do them synchronously because they may potentially block. And then once that happens, it's going to start to build up, and then you'll potentially have an ANR happen. Stagger SDK initialization. Essentially, if you guys are familiar with the term of lazy loading, utilize that tremendously. So when you start your game up, do you really need to load up that particular ad SDK or analytics SDK right at the very beginning? Or maybe or that push notification SDK that you're using? Or do you only need to load it up once the user gets completely through the onboarding process or the main funnel? Like then do it then. Like you don't necessarily have to fire them all up at once. It's convenient and it's easy, but if you kind of stagger it out, it's going to be less stress on the actual, on the whole system, which is going to be a less chance for an ANR. Do an audit on all your third-party libraries. Going back to the example of the random SDK you got off of GitHub or something. Look at that code. Who knows what they're doing in there? They could be like mining for Bitcoin. I don't know what they're doing in there. So you got to really make sure that you audit all of the third-party libraries, stay up to date with them, and make sure that you have the latest and greatest fixes. Always make sure to go to the GitHub, go to the forums, make sure that, look at the community, look at the conversations going on. Maybe people are getting ANRs, and maybe the creator of the SDK is oh yeah, guys, we're getting a fix in there, but it's in this next version. Make sure to always update, always stay up to date. Be mindful of long-running processes in the background. So I was kind of speaking to this a little bit earlier. This is, I think it's worth saying again, just be very mindful of this. The majority of ANRs that I see are when the app is in the background. And that's because people are doing things in the on pause, which is totally fine. Like a lot of the times is they're saving information about the user to somewhere, they're sending analytics off, all very important things. But you just need to be mindful about what exactly you're doing in there and how important is it to do it at that point in time. Maybe you don't necessarily need to send off that little piece of data at that time. Maybe you could do it, a little bit earlier before it's, set in the background or so on. So you need to be very, very mindful of that. Utilize the Unity profiler and Android Studio profiler. So, and this includes just a normal profiler and a GPU profiler, kind of going back to what I was saying earlier about that one particular ANR dealing with the GPU. So always utilize the profiler to look to see where you're getting spikes, like where you're using lots of threads, where parts of your application are more busier than other parts. And then once you spot that, dig into it deeper and start figuring out ways that you can optimize it. So that is incredibly helpful. And then the Android Studio profiler. I don't know how many of you are aware, but you can export out your project to an Android Studio project and actually open it up in Android Studio and utilize the wealth of tools that they have there to actually break down and analyze how to see what's going on inside of your game. Remove support for lower end hardware when not needed. When I bring this up, a lot of they're like, whoa, wait, money is gonna go bye-bye then. What are you talking about? Don't do that. We're not gonna do that. Our product people are gonna go insane or something. No, so what I mean is that just go into Google Play and you can actually see all the stats to see how much money you're making and on what devices you're making it. If you see that these low-end devices, you're not making a lot of money from them, but they're giving you the most ANRs, then the logical next step would be just cut them loose, right? So, and I did have a few customers that they said they did this and it didn't harm their profits that much. and they saw a huge reduction in ANRs, and they got down, it reduced, and made it so that they were no longer kind of in that threshold that Google looks at for marking you and kind of making it harder for you to get found. So that's a really important one, and it's super simple to do. Just go into the Google Play console, just look to see where, how much of your profits and what devices, and kind of correlate that together. And if you're just seeing a lot of low-end hardware that's just really not giving you a lot of cash, then just give them the boot. Next bit of optimizations and debugging. Review changes between versions with the most ANRs. This has also helped a lot of people as well. Just like, once again, utilize Google Play, the Google Play console. Look at the versions and when you've released stuff, and then compare them. If version, like 1 is like getting no ANRs, but then version 3 is getting like 50% more ANRs, then clearly something happened in version 2. So then you can use that version number to then look back into your source code. Hopefully you're tagging your code, but you can look at that to see like, oh, okay, so version 2 got a huge spike, like something went wrong there. It could be that we introduced this new third-party SDK, or who knows what happened there. But that's a great way for you to kind of help narrow it down so you know exactly where something could have gone wrong. Use logging software such as Backtrace to create breadcrumbs, like Otto was speaking a little bit about that earlier. Super important. What we mean by breadcrumbs is essentially just little markers, like inside of your code when you have a scene and someone's doing something, like a character is jumping up and down or whatever, then just create just send off some little analytics to say like, character jumping or something. Just little breadcrumbs, little markers, so that way when you do actually get those ANRs come in, let's just say you had an ANR come in on Tuesday at 2 p.m. or something, and then you look at your analytics and you see that on Tuesday at 2 p.m., the character was jumping a lot or something. It won't give you won't tell you exactly what was happening, but now it's giving you more of a context and an idea of where it was happening. So that can help you kind of break it down and track where it was going. Of course, utilize watchdogs. A lot of things like Backtrace and other providers will have stuff built into there like that. Unity's Android Logcat, that's always a very valuable package because it allows you to see all the logs that Android is generating as you're using the application. And then, of course, just try and use lots of other software, like there's other providers like Sentry, there's like Datadog, there's all these different ones that can provide you tons of telemetry data, meaning like metrics, spans, and other logs and other very, very useful information that will help you measure performance, understand like over time, like how long things are doing, like is something more optimized in one area versus the other. So getting lots of that data is very, very handy. Utilizing Android strict mode to identify game performance issues and long I/O operations. This is something you can actually turn on right now. You can just go into your developer mode in any Android device, and it's a setting in there that you can just check off a box and you can turn on strict mode. Once you've turned that on, inside all the logs that are going to be reported back to you, it will start giving you kind of like messages and tips saying like, hey, we noticed you're doing a lot of threads here, or like, hey, we noticed that you're doing a lot more like I/O in this particular part, like maybe stop doing that. They won't say that, but the idea is that they'll give you valuable information about what's happening and where. So definitely try and do all these things if you can. So that's the end of my part, and hopefully it was informative. And of course, please upload symbols. Very, very important. And yeah, so up next is Neil.
So thank you. So far, so good. So I'm the manager of the Android team at Unity. So we've been doing a lot of stuff to actually, alongside all these tips and tricks, to actually help you, well, Unity to help you get off on the right foot. There we go. Right, cool. We get it. ANRs, if I could wave a magic wand, my job would be a lot easier if ANRs didn't exist. Okay? So, and they affect your bottom line. I'm sure you have KPIs around ANRs and crashes. I'm sure that these things are pain points for you every day. They're a massive headache, and they impact your revenue. Unfortunately, it's like finding the cure for the common cold. We can give you as many tools and as knowledge and as optimizations as possible, but there is no magic switch that will just turn them off. So that's what we're trying to do at Unity and working with Google, just to help and give you as much as possible to help you treat the common cold. So yeah, we've been working with Google. We've been working internally. The engine teams have been reducing the chances of ANRs. Our professional services team have been sharing this expertise and helping developers, helping our customers with all the best practices, like you've seen before. Level Play has helped us with the ad mediation stuff. And as you saw, Supersonic publishes the Snake Crusher game. So the fact that we could work with all these people internally meant we could dog food stuff, which meant we could actually see what we were doing and see how good it was without just throwing it into the void and going, it works. But yeah, we are working directly with Google. We have an open dialogue with them. We speak to them regularly. They're improving the UX in Android Vitals specifically for Unity stuff. And also they're going to publish an ANR playbook, a comprehensive set of documentation that we'll link to later. So it's probably worth a read. But yeah, we're committed. We're going to give you the tools and the resources and the knowledge to reduce these ANRs. So here's the first one. We have, in the latest update, we've made some cool changes internally on the on-pause logic. So we found out that sometimes during pause events, the game and Android there was too much going on. We were waiting too long for things to finish and tidying up, which could cause ANRs. So we tweaked the timing. So now the timing is short enough that the 5-second limit will not be hit, like by accident. So Unity main, the thread earlier, prioritizes your app's execution without breaching the foreground ANR threshold. But this does not cover your game loops automatically. You still need to do your auditing, your checking, your debugging, but just be happy in the knowledge that Unity won't sit there waiting forever for these low-end devices, long-running processes. We will cut them adrift. So you still need to do that. You can actually tweak this timeout. It comes shipped, I think, to a non-ANR number, but you can tweak it. I haven't written the code up here, but you can find it in our docs. If you extend the activity, you can use the Unity player for activity or service synchronization timeout in Java. So you can set that. You can use C#. There's using Android Java classes call static functionality to call set timeout for all. And yeah, you can set it in C# and Java. This only applies to things running off the Java activity. If you use GameActivity, ignore this, because there's no such thing as internal timeouts. GameActivity, it just does on pause, and then everything is left to pause, really. So you'll find that these tweaks are in the versions of Unity shown, 21.3.34, 22.3.16, and 6, including 6 preview. So this is I'm going to leave you to drink this number in, because we've had customers come back to us and say they've had 20 to 40% reductions in ANRs when they've updated to a version that includes all this stuff. So yeah, drink this number in. I'm very proud of it. And the versions, there again. So make sure, 21.3.34, 22.3.16, and Unity 6. So yeah, make sure you update to those, because if you're not doing that, you want to get yourself on the best foot possible. Update to those versions, because you'll probably find a reduction. And please reach out if you have a support engineer with us and let us know how you get on with these things. Cool. As everyone has told you before, you need to upload your symbols. Surprisingly, few people actually do it. Google recommend it, they push it, and it's probably one of the best things that you can do. So in Unity 6, we now automatically, well, it's a checkbox, but you can embed your symbols into your app bundle. So as you see before, it just does it now, and you can upload it with your app bundle, and symbols are there. We still have the old way of doing it, so you can export a zip file, because we know some crash reporting services did things the old way Unity did it. We still support that, don't worry. But if you're uploading an app bundle to Google Play, just check the box. You'll get the symbols with no extra work. It's all good there. That one is in Unity 6, including preview. Ta-da! GameActivity. cool. So this one is pretty cool. So it's part of the AGDK, the Android Game Developer Kit library in Android. So it enhances lifecycle events, input, text input, and it builds upon native activity to offer improved threading support. And as I said before, is part of the Android Game Developer Kit. So essentially, a lot of stuff that goes on in there removes internally some of the JNI computational expensive stuff. So it's a lot more stuff is native in there. So there are 3 things I want to call out about GameActivity. So it improves threading for lifecycle management, input handling, touchscreen keyboard events. So it's part of the Android X GamesActivity package, which manages all this on a separate thread already. So Google has reported a massive reduction in ANRs for native Google apps using GameActivity in Kotlin, and they're really confident that this will help in Unity as well. Yeah. So independent updatability, I'm sure people can get frustrated that sometimes when Unity updates, the tooling is maybe one step behind bleeding edge. With GameActivity, it's in your build Gradle. You can update it manually if you want. So if there's a new fix or feature or something you want to try out, you don't need to update Unity. You just need to update the GamesActivity package. We also have a Unity to GameActivity bridge. It's a bridge layer that sits between GameActivity and Unity, so you can customize or modify greater flexibility in events like pause and resume. You can manage what happens in there, which was not possible in previous activity-based setup. We kind of squirreled that away in classes.jar. Now there's a bridge that you can tweak yourself. So it does all this cool stuff and is available in Unity 6 and preview. Cool. So we have the ApplicationExitInfo API, which some people may use previously, but if they've done the native Java stuff themselves. So it's an Android API that is designed to help you diagnose crashes, diagnose ANRs, and basically the reason why your app quit. If you're using Unity 6 or later, you can directly call it from a C# API, and it basically tells you, what happened on the next boot up, obviously. So you can retrieve detailed information about the reasons behind the app exits, including crashes, ANRs. You get tombstones, you get additional context, all the stuff that you would normally see on Google Play. You can get it in the next boot and do what you want to at the time. So you can also seed this API with state data, as we said before, little breadcrumbs. Now it's not big. You're limited to a 128 byte array. But it's enough, maybe a bit mask, some just little things that you can put in there to kind of help you narrow down. If we had lots of ANRs and when the system rebooted, the character was jumping, you were loading an ad, something where people got phone calls, you can able to actually find the area, which can be really helpful if the stack trace is nonsense. So you can do all that. But yeah, so this is available in Unity 6 preview onwards. There are some third-party solutions and plugins you can use, but again, if you find them, audit them. But it's a really helpful API, especially to see exactly what happened. And there's a nice table of all the things that we have doing here. So again, Unity 6 gets everything. The optimizations we've backported across all the LTSs that we currently support. Sorry if you're on 2020 or below, we don't support that anymore. So I'm afraid you're on your own there. But yeah, I'll let you take a minute to see that and see what we've got everything here. This is not everything we're doing. There will be more stuff, and I wish I could show you my backlog. But we're working with Google to integrate more APIs, more techniques, more optimizations, and stuff will happen in Unity 6 and onwards. Okay, so we are committed to helping you, committing to adding new stuff alongside development skills. We're also in this fight with you. And thank you very much for coming to listen to the 3 of us. That is the Google developer link. And we're here for questions. Thank you.